So we are going to start talking about tangent problems today, which is really, we're kind of going to be using this idea until Christmas for sure. So if we are talking about a tangent line, okay, we know what the tangent function is, but a tangent line is just a line that touches a curve. Okay, so for instance, if this is my curve, that pink line is a tangent line. It's tangent at point P. And there are lots of tangent lines on this graph. Anywhere that I put a point, we could draw a tangent line. And if I were going to draw this tangent line, it's touching the curve the same general shape, so it would have to be something like this. I did not draw that perfectly. It's not intersecting, not going through, it's just like touching and bouncing off the curve right there. So if I were to draw lines right here, what would they look like? Would they be increasing or decreasing? Decreasing. Okay, what would happen if I drew one right here? It would be straight across. If I could draw a straight line, these would start going up again. So they show the same general shape of the graph. If the graph's going up, the line should be going up. If the graph's going down, the lines are going down. All right, these lines have a lot of different applications. So what we are going to do today is try to come up with the equation of these tangent lines. Now here's the thing. If you're going to write the equation of a line, what information do you need? You need either 2 points or a point and a slope, right? We had to have the 2 points so we could get a slope. I gave you a single point. All right, you could draw yourself a picture if you wanted. Y equals x squared. We know what that looks like. 0, 0, 1, 1, negative 1, 1, just a parabola. I am trying to draw or get the equation of a line at this point 1, 1. Okay, so for instance, that line. Now, can I just look at that line I drew and pick 2 points on it and get my slope from there? No. Did I do a great job drawing that line? No. It is far from perfect. So that might get me close, but it's not going to get me exact. We know, how do you find the slope? So let's say we were going to calculate that. Let's look. Our other point we don't know, x, y. But we know that y is equal to what in this problem? Okay, so if I were trying to find the slope between these 2 points, we have to do y2 minus y1 over x2 minus x1. So I have a formula for slope. Just keeping a generic point and calculating the slope between them. Okay. So what we are going to do is make a table of values to help approximate this. Because what I can do is I can find 2 exact points on my parabola, but I can't get 2 exact points on my line itself, right? So let's think for a second. If if x is 2, and I use this point, I could get the slope of the line going between those 2 points. Now, is that exactly my tangent line? No. Is it reasonable? Maybe. So we're going to make a table. I think I left you guys a blank slide after this as well, so we can kind of approximate it a little bit. So on my table, I'm going to put x, y, and m. All right, so this was when x was 2. What's our y value if x is 2? 4, because it's just x squared. So you could either calculate the slope between these 2 points, or if you just wanted to use your formula that we already derived, you can use that. You wouldn't necessarily have to put the y in the table if you were just using this. I just want to explain what we're doing. So if I did my slope, 4 minus 1, 2 minus 1, 1, so we get a slope of 3. Now, was that one exactly my tangent line? No. What if instead I had picked when x was 1.5? Is that one going to be exactly my tangent line? No. Is it closer than when x was 2? Yeah, okay, let's try that. So if I put in 1.5, you can either plug it in and get your y and do your slope, or use this formula that you got for your slope. That is completely up to you guys. So I'm not going to require you to show me the y's. If you did, so you could keep it in fraction form, or you could just do 1.5 squared, so 2.25. So get your slope. You guys can use the calculator. We have 1.25 over 0.5 over 2.5. Is that the closest I could get to the real tangent line? No, how would I get closer? Okay, what if I did 1.1? That would be closer. So if I put in a 1.1. Again, the y column is optional. If you did that, you would have 1.21, or you could just plug into your slope formula. So we get 0.21 over 0.1. You get 2.1. Is that the closest I could get? No? Give me something closer.
1.01.
Okay, let's try that one. So if I put in 1.01. If you did the y, 1.0201, plug that into, get our slope. And we get 2.01. Alright, is that the closest? Could I do 1.001? We could keep playing this game all day, couldn't we? Can you tell, what does it look like our slope is getting close to? 2. Alright, let's test that theory. So, we only picked x values that were bigger than 1. Could we have came at it from the other side and done values smaller than 1? So, what I'm saying is, instead of using those lines, what if instead I'd started when x was 0 and done this tangent line, and then maybe when x is 0.5 and did that tangent line? Could I get closer from that direction? Yeah. Let's do one more table. Do you guys all know where I'm getting my x, y, and m? Okay. Do you all use the y, or are you just plugging it into your m? Okay. So totally up to you. You can use all 3 columns, or you could just do x and m if you were comfortable with that. So maybe if I started at 0. Okay, so you would get -1 over -1, which is 1. If I went with 0.5, so 0.5 squared, or just plug it into this formula. What could I do? We're trying to get close to when x is 1. What would be closer? 0.9. Okay, if you did a y, that's 0.81. So then y2 minus y1 over x2 minus x1 gives me 1.9. Give me one more. What would be closer than 0.9? 9. Okay. So that would be 0.9801 if you did it that way. And we get 1.99. So we said this side looked like the slope was getting close to 2. Does this one also look like it's getting close to 2? Yes, so we've checked it. What we just calculated there is called a limit. it's looking at what our slope was approaching. You might see it written, we will talk a lot about limits later in this chapter, but we see L for limit as x was getting closer to 1. My slope, which the formula for that was x squared minus 1 over x minus 1. And we found that it was getting closer to 2. So we'll start seeing that kind of notation. It's telling me when the x is getting closer to this, my slope was getting closer to 2. Now, what did I ask you to do with this whole thing? What were we trying to find? Okay, equation of the tangent line. So now, we now know our point was 1, 1. We found our slope to be 2. So if you plug into y equals mx plus b, our y-intercept is -1. So the tangent line is y equals 2x minus 1. We found an equation for the official tangent line. To get this slope, we were using what are called secant lines, which is just a line that goes through 2 points on the graph. So I did put that definition on there just so you would have it. So secant line is a line that intersects a curve more than once. We aren't going to use the limit notation a whole lot this section. We'll practice that more. But I did give it to you already for this, and I did have another slide for that. So the slope of the tangent line is the limit. So it's always going to be the limit as x approaches some number of our slope formula equals a number. Okay, that's kind of the limit notation. X is getting close to a certain point. You have to know what function you're looking at and what number it's approaching. So we will see this a lot more later on in the week. The next slide, I just put a diagram of what we really did there. So the line we were trying to find was the pink one, and we were using secant lines, those blue lines, to approximate our slope. And to make it more and more accurate, the 2 points had to be closer and closer together. It's not enough just to verify it from one side. We do have to look from both the left and the right. So when we're doing these, we will make 2 tables. And I'm going to ask that you put at least 3 points in a table so that you can actually verify it is approaching, because if you only do 1 or 2 points, it's really hard to tell. So we will be looking at both of those. Let's practice some. Approximate the slope of the line tangent to y equals negative x cubed plus 2 at the point x equals 0 by making a table of values for the slope of the secant line. Then write our equation. So we'll have to have 2 tables I want at least 3 points in each. And the x that we have to be getting closer to is 0. Alright, so if I were looking at things bigger than 0, I might do 0.1. What would be even closer? 0.01 and 0.001. Alright, so what would I do from the negative side, smaller than 0? Negative 0.1. So here's what we're going to do. We have to know the point we're finding our slope between. Okay, the x is 0. Can you find what y is when x is 0? What would you do? Plug it in right here. So y would be 0 plus 2. 2. Alright, so now I'm going to plug this in. So we can use our calculator. So if I have negative 0.1 to the third plus 2, I get 1.999. Then we can do our slope. y2 is 2 minus 1.999 over 0 minus 0.1. And negative 0.01. Okay, does everyone understand where I got both of those numbers? Let's do one more together and then I might have you guys fill in some. So if I do 0.01, so I would have negative 0.01 to the third plus 2. I get a 1 and 6 9ths. So now we do our slope. 2 minus my 1.99999 over 0 minus 0.01. And I get negative 0.0001. Third one, if you plug it in, you get 1 and tons of 9s. Like 9 of them. And if you do your slope, you guys get for your slope. So what does it look like this is approaching? 0. Okay. Let's check the other way. Do you guys want to try plugging some of these in on your own? I'll go ahead and work it as well and put my numbers up here so you can check. Remember, every time you're putting this into your equation to get your y, and then we're doing the slope between the 0.02 and the point in our table. Slope is approaching? Yeah, this one also appears to be approaching 0. So if they're both going to the same thing, then that means my slope of the tangent line is 0. So now can we get the actual equation of the tangent line? Use our point, 0, 2, and our slope 0, y equals mx plus b. So our y-intercept is 2. So the equation of the tangent line, y equals 0x is just 0 plus 2, so y equals 2. It's a horizontal line at that point. Do you guys like having the table for the, do you like having the y column, or would you rather I just wrote a formula for the slope and left off the y's? Do you have a preference? You like having the y so you can think of it as subtracting order pairs? Okay. Let's do we need another one like that, maybe? Or are we doing it? Let's try, okay, we'll add this in. If the equation of the tangent line to y equals negative x squared plus 3 at the point when x is negative 2. All right, so we have to have our two tables, x, y, m. We need to be approaching negative 2. So what number could I start with? And from the other side, so just a little bit smaller than negative 2, so maybe negative 2.1, negative 2.01, negative 2.001. All right, we are going to plug these in to get the equation to get our y. The point we're finding the slope between. If you put negative 2 into this equation, negative 2 squared is 4. The opposite of 4 would be negative 4. Plus 3 is negative 1. All right, let's divvy up the work. Sam, do you want to plug in negative 1.9? Do that one. Anna, do you want to do negative 1.99? Cole, do you want to do negative 1.999? And you can check in on that one. Hunter, do negative 2.1. Bryson, do negative 2.01. Tanner, negative 2.001. What'd you get when you plugged that in? Did you go ahead and calculate your slope? Okay. So if we did our slope from that, my y2, so negative 0.61, minus my y1, negative 1, over x2, negative 1.9, minus x1, my calculator's having issues. So negative 1.9 minus negative 2. And what do you get for that slope? Anybody else get something different? I got 3.9, but I put that in right. Make sure when you do those minus the negatives, it'll turn into a positive. All right, for negative 1.99, what'd you get for the y?
Negative 0.967.
So, now if we set that up, negative 0.9601 minus negative 1 over negative 1.99 minus negative 2. 3.99. Alright, my negative 1.999, what did you get? So for our slope, y2, so that number, minus negative 1, so plus 1, over negative 1.999, minus negative 2, or plus 2. And you get 3.999. So what does it appear this side is approaching? 4. Okay, let's check the other one. So my 2.1, what did you get? Or sorry, negative 2.1. What did you get when you plugged that in?
Negative 1.41.
Okay. So our slope, we have negative 1.41 minus negative 1, so plus 1, over negative 2.1 minus negative 2. And what did you get when you plugged that in? Negative negative 2.01. What did you get on that one for the y?
Negative 1.0401.
Okay. Have you done the slope for it?
Yeah.
What'd you
1.01.
Alright. And Tanner, what did you get for yours?
Negative 1.004001.
And what did you get for your slope?
4.001.
So what are my slopes approaching? 4. So we can see as my x value is getting close to the negative 2, my slope is getting close to negative 4, or to 4. So the slope of our tangent line is 4. So now we can write the equation. Y equals m times x plus b. Add over 8, so b is 7. So the equation of our tangent line is y equals 4x plus 7. That means at that particular ordered pair, that would be the line that touched it and bounced off. Any questions on this? Alright. I think I'm going to stop here for today. So we are going to finish this tomorrow, talking about how it's related to velocity. But I have just a handout for you for homework. If you write big, you're welcome to use another sheet of paper. This is due on Wednesday. No, wait, yeah, today's Monday. So due Wednesday. Really, it's 5 questions. You could probably do 1 through 4 right now. 1 through 4 are just what we have been doing. I expect 2 tables with at least 3 points in each.